So we're just going to talk about some of the patterns that we see on the periodic table. For example, this first row, the alkali metals. All alkali metals are explosive when they encounter water. So on the back of your paper, just write alkali metals, group 1. With water. So alkali metals, group 1, explosive with water. Go ahead and just write that down on the back of your periodic table. One kind of interesting thing that we see about the periodic tables, and so we know every single one of these in this group, because remember groups are columns. And one interesting thing we've learned about groups is that the farther down the group you go, the more reactive they become. And so lithium, if you had a huge chunk of lithium, I think we watched a video on this actually, a cool science video. You have a huge chunk of lithium and you throw it in water, it's going to explode, it'll catch fire. But if you had the same amount of rubidium and you chucked it into water, the explosion would be much more immediate and much, much bigger. And so as you go down, it becomes more and more reactive, and those reactions become bigger and bigger. We're going to also talk about these alkaline metals. So also write down alkaline metal on the back. Group 2, that's what I want to write. Produces light when heated. Okay, so this group number 2, they produce light whenever they get heated. And just like these explosive, when meeting water elements, these ones also get more and more reactive as you go further down the periodic table. And a lot of them get hotter and hotter as you ignite them and make them produce that light like we did with the magnesium. As you go down, they'll get hotter and hotter. And so, like a lot of mechanics or people who use this stuff as like steel for cutting metal and other things like that. They'll use some of the ones down farther because they burn hotter, and so they can burn things easier that way. But because they get so bright, that's why they have, part of the reason why they have that huge metal thing that has a very black glass in front of it, so that it dampens the light coming in from these different elements. And then we got transition metals. Okay. Transition metals. This is the biggest category. And they conduct electricity really well. So all of these here, we call them transition metals, and they're very good at conducting electricity. Some better than others, depending on which element they are. But anytime that you use something that needs to conduct electricity with our electronics, most of the time it's going to be using one of these elements. And over time, we've learned which elements do it better than others. And so over time, computers have gotten better and faster as they learn different tricks on how to create the electronics with these different elements. Yeah. Okay, so you mean like when we get disruptions and the power goes out? Yeah, so that has to do with the connection. So sometimes the electrical connections get disrupted at the power plant when we have storms and stuff like that. And once those, once that connection is disrupted, then that's when you have the power outage. Yeah. And sometimes it's like the storm like knocks something loose or knocks a power line down or something like that. And other times it just got in the way of the connection. Okay. Let's see, I think there's two more I want to talk about. Three more. So we're going to talk about three more. We're going to talk about the nonmetals, the halogens, and the noble gases. Can we have these three down? Okay. Everybody, anyone still need time? Okay. So nonmetals. Okay, so nonmetals are gases at room temperature. And some of, yeah, we'll go with gas. And so these nonmetals, here, they make up quite a bit of stuff in the world. And there are some of the few elements that are not metallic or metal. All of this right here is all a type of metal. And so the majority of elements we know of are types of metal. And just these ones here are not types of metal. And so there's very few elements in our world that aren't metal. And so those same elements are used many, many times throughout many different compounds to make lots of things. Okay. In this row, group, let me see, group 17 are the halogens. So the halogens are the most reactive nonmetals. And one of the reasons we actually find that it has to do with electrons. And we won't dive too far into the periodic table and how the electrons work. But these halogens, these particular elements, are very, very greedy for another electron. And so they try really hard to find any electron they can and take it. Because they try to take that extra electron, they are very, very reactive. If you have pure element of any of these things, most likely it will react with something around, unless you have it in a container to not allow it. And so these typically need to be very well taken care of when you have them, or creating salts. Halogens actually create salts really easily. They combine with these elements actually to make different salts. You guys know of table salt, sodium chloride, and NaCl is the chemical formula for it. But sodium chloride, that's this one, sodium, with this one, chlorine. That's table salt, that's what we eat every day. But in science, pretty much any non-metal with one of these alkali or alkaline metals creates a salt. And there's tons and tons of varieties out there. And that's kind of the safe form that we keep these halogens in. is in a type of salt. If those halogens are pure, they become very reactive and produce all kinds of different chemical reactions. Most chemical reactions that I learned of in college in my chemistry classes had to do with these halogens in one way or another. All right, last one, noble gases. Group 18, and they do not react with other elements. So these noble gases, they are actually very satisfied with how they are already, and so it is very, very difficult to get noble gases to react with anything else. Most often they won't do anything. One thing we did discover about noble gases that we use quite often is that if you send electricity through them, they make neon colors. They light up and with those neon colors. And so those neon lights that you see, they are made out of noble gases. Okay.